Hi, we're going to do some area problems now. Hopefully you're all familiar with how to find area of a rectangle. So we need the length times the height, or some people call it the base, and the height or the length and the width. It doesn't really matter. In this case, we want to do 3.5 multiplied by 6.1. So we're going to do some multiplication with decimals, which we will do by ignoring the fact there are decimals in there to start off with. So my calculation is actually going to be 61 times 35. I do my multiplication probably the other way around to most of you, but bear with me. I start off with multiplying in the tens column, so I have a 0 here, and I do 6 5s, which are 30, carry the 3, 6 3s are 18, plus that 3 gives me 21. And 1 5 is 5, and 1 3 is 3. Which gives me 2,135. But obviously that is not my answer because I need to put in 2 decimal positions. So the answer is 21.35. And importantly, we're talking about area, so my units would be centimetres squared. So my answer is 21.35 square centimetres. Now we're going to move on to look at triangles. Area of a triangle. Area of a triangle is a half base times the height, which is the same as base times height over 2. That's just two of the more familiar ways you'll see of, you'll find the formula written. So the problem we've got here, the base is 12, the height, and this is the perpendicular height, is 7.3. So I can substitute those into my formula, and I can do a half of 12. That's nice and easy. So my formula becomes 6 times 7.3. So that's what I need to work on. 6 times 7.3. So I'm going to do that as 73 times by 6, and then I'll just put in my decimal position. So 6 3s are 18. 6 7s are 42, plus 1 is 43. So putting my decimal position back in, my answer is 43.8. Let's, whoops, say these were all in centimetres. So it'll be centimetres squared. So that's our triangle, a half base times the height. The next one we're going to look at is a trapezium. The formula we need here is half the sum of the parallel sides times the height between them, or the distance between them. Again, it's the perpendicular distance between A and B, which are our parallel sides. I know these are the sides because they've got the little arrow markings on them. So again, I'm going to substitute into my formula. So it's a half of 12 plus 18, and then I would multiply that by 4.1. I'd multiply it by the distance between them. So I can do 12 plus 18, gives me a grand total of 30. Half of 30 is 15. 15 times 4.1. So I can do that again using long multiplication. So that's 15 and 41. 5 times 4 is 20. Can't be 6. 5 and 1. So that equals 6. 1 5. I've got 1 decimal position to put back into my answer. So 61.5 again. Should really have put some units in. 61.5 square centimetres. Now, the very last area that you need to know is the area of a parallelogram. And I should really have put some labels on here, just so you're absolutely sure you know what the shape is. Now, the area of a parallelogram, if you think about it, if I was to chop off this triangle here and move it over here, I would have a rectangle. So the area of a parallelogram, the formula is the same as the area of a rectangle. It's the base times the perpendicular height. Now on this example, I've been given the length of one of the slanted sides. I just ignore that. I don't need it. to work out the height, the area. So this would be 5 times 8.4. Now I know 10 times 8.4 is 84, so 5 times is going to be half of that, so that's 42. 42, again, centimetre squared. Okay, I hope that's helpful. The best thing to do is just go and have practice. Obviously, you can get some shapes that are combinations of the shapes that we've looked at, and you just break those composite shapes down into shapes that you can work the areas out for, and then add them all together. Hope that's helpful.